Newton's third law of motion. See, the Newton's first and second law of motions talked about the impact of applied force on motion and how we can measure the force, like force is equal to mass into acceleration and things like that. Whereas in the third law, he gives us a relationship of action and reaction of the forces, which is nothing but pair of forces acting in opposite directions. So he talks of the opposing forces. Let's see with an example. Let's say there is a wall, which is obviously on the ground, and a boy is on a skating wheels and trying to push the wall. Now what happens? He is applying a force on the wall, whereas the boy is also experiencing a force by the wall. And how we get to know this? He moves backward, because the skating roll, since he is on the skater, that moves backward. So basically what happens? The boy moves backward because there is a force on the boy. Now we know the pair of forces we are talking about is force on the wall by the boy and force on the boy by the wall, which creates the boy to move backward. There is a pair of force. Let's see one more example in which there is a gun. This is the bullet, and when the gun is triggered, the bullet moves forward and the gun recoils. So there is a recoil force on the gun and there is an accelerating force on the bullet, and that is the reason the bullet moves. It accelerates. Again, in this example, there are two forces. The bullet accelerates and moves forward with a force, and the gun moves back with a recoil force. There is a less acceleration by the gun. We don't see the gun moving too much because the mass of the gun is higher than the mass of the bullet, because of which we see less acceleration by the gun and more acceleration by the bullet. So what we understand from these examples and others, like a sailor, when the sailor jumps forward, boat moves backward. So in any lakes and all, when you see a sailor with a sailing boat, when he jumps into the water, then the boat moves backward. This is again forward, backward forces acting on the two objects. You also may be observing a man pulling the cow with a rope, and when he's trying to pull the cow, and the cow moves backward. So there is again a forward, backward actions and the forces incorporated. So from all these examples, we understand that when one object exerts a force on another object, the second object instantaneously exerts a force back on the first object. That means there is a mutual force exerted on each other. So this is what Newton has studied and came out with a law in which he says, to every action there is an equal and opposite reaction, and they act on two different objects. And we have seen everywhere they are in pairs. The forces are equal in magnitude but opposite in direction. How do we experimentally see Newton's third law? There is a way of doing it. Let us take two springs tied to the wall on one side. This is basically a spring balance, and another spring balance which is hanging freely but which is connected to this spring. Let us say this is a spring A and spring B, and there is a boy who is exerting a force on it. He is pulling the spring. So when the boy is pulling the spring balance B will show a force of 4 newtons, and the spring balance on A also shows a force of 4 newton. Basically what happens in this case, when the boy pulls the balance A, it exerts a force of 4 newtons on balance B because he is pulling it from this hook. So when he is pulling it, then there is a force exerted on this spring balance. So it shows the reading 4 newtons. 4 newtons is the force that is exerted by the pull. And in the same manner, the balance B pulls back the balance A with the equal force of 4 newton, but in opposite direction. So you can make out from this experiment that both the spring balances are showing the same reading 4 newton when we pull the balance A. So it shows that the force of action is equal to force of reaction. So force of action is by pulling A, there is a force of action on B, and which is again pulling back A, there is an action on balance A. So we understand from this example that force of action, or from this experiment, force of action is equal to force of reaction, but in opposite directions. As the Newton's third law says, the force always occur in pairs. For example, Newton's third law studies the pairs of forces. So let's see an example like magnet and iron piece. Magnet exerts force on it and iron piece also exerts. And falling body, let's say a falling stone on ground. So ground exerts a force of gravitational pull and falling stone also exerts. Otherwise, if it is only in one direction the forces, then there will be an issue. When there is a force only from one direction and the other object is the one which will keep getting hit. So for example, let us take a stone on the ground and the weight of the stone. Later on we will understand from the gravitation. So due to the pull by the ground, the weight is pulled down, and which is action. As per Newton's law, action and reaction, this is the force of action. Whereas there is an opposite pull by the stone, which is the force of reaction. Imagine in this case, unidirectional force is there, like gravitational pull, pulling the stone down, and the stone will disappear into the ground. But the stone also resists its pull, and that's why it is where it is standing.